Yes, good morning, students.
Good morning.
Good
Morning, Mr.
Morning, sir.
Okay, I am fine.
Morning, Mr. Morning,
Okay, إتايا سؤالين إيش thank you.
يتعيل مستر.
إيش دمساتشون كنسونا تكتاتلو ميوت الدرجة المانن نتنكو ميوت. Okay, do you remember what we have seen in our previous discussion
About velocity.
about velocity and speed? Okay. In our today discussion, we are going to see qualitative exploration of uniform motion and the uniformly accelerated motion. Okay, under this one, we are going to see the definition of what is uniform motion mean. What is the definition of uniform motion? And how we can represent graphically uniform motion and the uniformly accelerated motion. In our today discussion, we will see or we will focus on uniform motion. What is uniform motion or the definition of uniform motion? Do you know what's the definition of uniform motion?
Yes.
What is okay, uniform motion is the motion of a body or an object on a straight line with a constant velocity or speed, with a constant velocity or speed in a given direction, okay? And in uniform motion, speed or velocity is constant and the acceleration is zero, okay? Acceleration is zero. Because of why acceleration becomes zero? Yes. Yes, who said, mister? Because of what?
Me.
Because, huh? Yes, ይቆራረጣል ምን አልክ? Okay, acceleration is zero because of what? Why? Because of what?
Because it's constant.
Huh? Okay.
Because it's
there is no change of velocity. No change of velocity. Why? For we will going to see. Acceleration means, look, acceleration is equal to change of velocity over
time taken.
Yeah, if there is no change of velocity, our acceleration become zero, okay? Our acceleration become zero. Therefore, uniform motion is the motion of an object on a straight line with a constant velocity or speed in a given direction. Speed in a given direction means it become velocity, okay? It become velocity too. Therefore, in uniform motion, speed or velocity is constant. Acceleration is zero. You must know this one. You must know, okay? You must know the definition of uniform motion as well as speed is constant as acceleration become zero, okay? As acceleration become zero. Look, consider the following table, distance travel in each second. This table is visible. This table is visible for you. Therefore, if you take this one, when the time is zero, the distance is zero. Therefore, speed become zero. And sorry, whom you are, for example, you see, Fulmono. No need of another additional sound, please. Mute your sound. Okay. When the time is equal to 1 second, the distance covered is or traveled is 2. And when the time 2 seconds, it is 4, 6, 3, 4, 8, 4, 10, 5. This shows uniform motion, okay? Uniform motion. For example, the speed of this motion is constant. The speed of this body is constant. How many? How many? At every point, 2 meter per second, 2 divided by 1, 2, 4 divided by 2, 2, 6 divided by 3, 2, 8 divided by 4,
2.
2, 10 divided by 5, 2.
2.
At every point, if you see 2, the speed of this moving body is constant, which is 2 meter per second. So, in uniform motion, the distance covered in equal interval time is equal. In equal time interval, the distance covered or traveled is equal. Therefore, this table shows what? Uniform motion. Why? For speed is equal to distance over time taken. Distance over time taken. Therefore, you can take one of them. For example, 2 meter over 1 second, which give for you 2 meter per second. So in each second, this moving body covers equal distance, okay? In each second, if it covers 2 meter in 1 second, it covers in 2 seconds 2 meter, 4 meter, okay? 4 meter. So this table shows uniform motion, Okay. Based on this one, we can plot or we can draw the graph of display distance time graph, speed time graph, and acceleration time graph. Okay, we can plot. So this table shows that distance is increased by 2 meters in each second. 2 meters in each second. Whom you are simply talking, please, sorry. Huh? Don't enter additional sound, please. Don't enter. Or don't talk. Okay. The table above, or this table shows that the distance increases by 2 meters each second, and this distance, this indicates that speed is constant, which is 2 meters per second, Again, this again indicates that acceleration is 0. From this table, acceleration is equal to 0. For example, if you take,
Yes.
or if you wanted to calculate the acceleration of this graph, for example, between this point and the final point, if you wanted to calculate, you will get 0. Why? For there is no change in speed with a certain direction, or there is no change in velocity. The velocity is constant. 2 minus 2 give for you 0. 0 divided by any number, it gives for you 0. Therefore, acceleration is equal to 0. Why? For because of there is no change in velocity. There is no change in velocity. If there is no change of velocity, your acceleration becomes 0. Therefore, in uniform acceleration motion, speed or velocity is constant, acceleration is 0. Okay? The other point, based on the table above, the S against T, B against T, and the A against T graphs are plotted below. For example, look, S against T. For example, on y-axis, maybe my graph may be not straight as much. If it becomes straight, This one is distance in meter. Here is time in second. Time in second. When 1, 2, 3, 4, 5. On y-axis, 2, 4, 6, 8, 10, and etc. So when your time is 1, your distance coverage is 2. Therefore, it gives proportional. Okay, it gives proportional line. That means it seems like this one. Have you seen?
Yes. Yes, Mr.
Yeah.
Yes.
This graph is
Yes.
distance time graph. Distance time graph. So distance time graph or uniform motion seems like this one. Okay. Distance time graph of uniform motion seems like this one. Who you see? Again, I'm hearing some sound. Please try to mute it. Additional
Mister,
sound.
why don't you mute them?
Yes.
Why don't you mute them?
What you said? Sorry. Okay. This graph shows speed time graph. Speed time graph. We will see how we can calculate the slope of this graph. The slope of this graph. How we can calculate? We will see. Okay. Look another velocity time graph. Velocity against T graph of the above table. Again, on y-axis, you must draw or take velocity. And look, E in second. Whenever or at any time, what about your velocity? What was your velocity at any number? Huh? At any number, what was your velocity from your table? Huh?
2, 4,
2, 4.
6,
Is it
8.
your velocity? Is it your velocity? Have you seen the speed given for you in your table? What was the speed? At any or whenever time is increased.
Ya fiz mute como marcarlo.
Yes.
Mister, what page are you?
Page. Sorry. Textbook is not with me. Okay. Textbook is not with me. Huh?
Okay.
C and then qualitative exploration of uniform motion. Okay. See it next to unit 2 of velocity and speed. Okay. See it. Okay. What was your velocity or speed on this table? How many? How many?
2.
Yes. 2. Excellent.
Only 2.
Only 2. Look, it seems like this one. Okay. When your time is 1 second, it was 2. 2 seconds, 2. 3 seconds, 2. 4 seconds, 2. 5 seconds, 2. 6 seconds, 2. And etc. This shows uniform motion of the graph of velocity time graph of uniform motion. Whenever the time is increased, your velocity is constant. Your speed or your velocity is constant. For example, this is speed on the y direction. Have you seen? Speed with a certain direction gives for you velocity. Therefore, your velocity or your speed is 2 meters per second. 2 meters per second. Therefore, it seems like this one, okay? It seems like this one. So graphically, we can use by table and the graph, and we can express a uniform motion by such a type of graph, okay? Try to differentiate the difference between the first graph and the second graph. Try to differentiate. Both of them shows uniform motion, okay? Both of them shows uniform motion. Uniform motion. Let us see the graph of acceleration against t, or the graph of uniform motion, acceleration and the t, or time. Let us see together. Again, here is t in second. What about this one? Acceleration in meter per second square. Acceleration in meter per second square. Look, 0, 1, 2, 3, 4, 5. What about on this one? Maybe 2, 4, 6, 8. What about your acceleration on this one? Is there acceleration?
Zero. The acceleration is
Acceleration
zero.
was how many? 0. So simply this one shows there is no relationship between this graph. Therefore, your acceleration is 0. Your acceleration is 0. So in uniform motion, look, in uniform motion, acceleration is 0, velocity is constant, okay? Velocity and or speed is constant. Velocity or speed is constant. Clear? Clear?
Clear.
I think it is clear for you. Okay. Let us see the slope of displacement time graph. Graph can be calculated as follows. Do you know what is slope mean? Slope in your mathematics concept. Do you know slope? Look.
No.
In your
No.
mathematics concepts, follow me. Slope is equal to change in y-axis over change in x-axis. You know y-axis and x-axis? Huh? You know.
Yes.
So that means y2 minus y1 over x2 minus x1, okay? So the difference between 2 points, gives for you the slope of a given graph. The slope of a given graph. So on y-axis, for example, look, on y-axis, you do have displacement or distance. On x-axis, the given for you is time. Therefore, change in displacement over change in time. Slope is equal to change in displacement over change in time. That means distance 2 minus distance 1 over t2 minus t1. You can take from this graph, for example, you can take this one as t1. You can take on 2 points. Again, this one is t2, or t final and the t initial. Again, this one s1 and s2. You can take this one to calculate the slope. Again, you can take this point and this point, or from x-axis 1 and 2. Therefore, when we calculate the slope of this graph, the slope of uniform motion is equal to the speed or the velocity of the graph. The slope of the graph. Have you seen? Let us calculate on this one from the above graph. For example, take or 2 and 6 and 1 and 3, or take 8 and 2 and from x-axis, or the value of time 1 and 4. You can take any 2 points, pair of 2 points, then they are equal. Therefore, slope is equal to change in displacement over change in time. Your SC2, that means your displacement is equal to 8. Okay, 8 minus 2 into meter over 4 minus 1 into second. This one becomes 8 minus 2. How many? Huh? 8 minus 2.
6.
6 meter over 4 minus 1.
5.
3.
4 minus 1. 3.
3,
3 second. 6 divided by 3.
2,
2 meter per second. Have you seen the slope? The slope is equal to what? This slope is equal to with what? Huh? With speed. They are equal with the given speed in the table. Okay. This equal with the speed given in the table. Therefore, the slope of uniform motion is equal to the speed of the given graph, or simply is equal with the velocity or the given with a given direction. Okay. Therefore, from if in uniform motion one graph is given for you, you can calculate its speed, and you can find its slope, which is equal with its speed or velocity. Okay, it is speed or velocity. Have you understand?
Yes.
Have you understand?
Yes.
Yes.
Therefore, the slope of
Yes.
displacement time graph gives for you average velocity. Average velocity. In this case, velocity is constant. Velocity is constant. Huh? Do you have any question on this one?
No.
Do you have any
Sir.
question?
No.
Yes.
No, mister.
Therefore, if you don't have any question,
No.
please listen
No.
me. Listen
No.
me. In uniform motion of an object on a straight line with a constant velocity or speed in a given direction, and speed or velocity is constant. Acceleration is zero because there is no change in velocity. There is no change in velocity, and we can calculate the given speed into another from the given uniform motion, and the slope 2. We can calculate slope from the given given uniform motion. Okay. Have you understand what you have seen still now?
Yes.
Huh? Okay.
Yes.
Yes.
Okay. If you don't have any question, you must understand what is uniform motion, what is uniform motion, and the speed of uniform motion, acceleration of uniform motion, how we can calculate acceleration and the speed as well as slope of uniform motion. Okay, how we can calculate, you must know. You must know. Look again at these points. Okay, still now what you have seen is clear for you. If you don't have any question, we will summarize on this point. Next period, we will see about what? We will see about uniformly accelerated motion. Uniformly accelerated motion means a motion which is do have constant constant acceleration. Uniform motion do have constant velocity, whereas uniformly accelerated motion do have constant
Constant increase in its velocity.
acceleration. Yeah. In a certain time or in a given equal interval of time, the speed increase or the velocity of a body increase by equal
Are you there,
interval.
Mr.?
That means the in uniformly accelerated motion, acceleration is constant. Okay, acceleration is constant. Therefore, if you understand this one, in our next spread, we will see about uniformly accelerated motion as well as the slope of uniformly accelerated motion. We will see in our next spread. For today, I think enough for us. I think enough for us. If you have any question, welcome.
Bye.
If you have any question, goodbye. See you next.
Bye.
Bye.
Bye.